Welcome to the lesson on order of operations. As math problems become more complex and include different operations, it becomes very important to follow a set specific order of these operations to ensure the correct solution is achieved. So let's go through an essential definition of the order of operations. The accepted order in which basic arithmetic problems are solved. So to go through that basic order, we must understand. To understand this basic order, let's go through the 6 essential operations that fit in within this order. We first start off with parentheses, then exponents, followed by multiplication, division, addition, and subtraction. But how do they apply? How do we take a problem with several of these and begin to set the correct order of operations? So we take a look at a problem of 2 plus 3 times 5 minus 4. How is this problem solved? Do we simply read it from left to right and think, well, I'm going to add 2 and 3, then times by 5 and subtract 4? These questions lead us to think about how do we apply the order of operations. So let's write it out. 2 plus 3 times 7 minus 4. If we're following the order of operations, I start actually in the middle of the problem because that's where I find multiplication. And multiplication comes before addition and subtraction. 3 times 7 will give me 21, and I still write the plus 2 on the left and the minus 4 on the right. Now, since addition and subtraction are the same, they can be done in any order, but I'll generally start on the left, so 2 plus 21 will give me 23, and then minus 4 will give me 19. This correct order of operations gave me the only possible solution for that problem. So now I think about order of operations and not even seeing certain symbols, in this case, 6 times 2 plus 9. The 2 plus 9 are in the parentheses, with the 6 seemingly hanging out outside, which means the 6 is going to multiply everything that's inside the parentheses, but order of operations must be followed first. We're going to take a look at a problem just like this. Our example 1 is 7 plus 3, then the parentheses 6 to the power 2 minus 4 times 2. Order of operations tells us to start inside the parentheses, and then we go down the list and continue with the exponent. 6 to the power 2 is going to give us 36, a minus 4 times 2, and we can close the parentheses. Let's make sure we keep the 3 on the outside and the plus 7 all the way on the left. I'll deal with multiplication next and multiply the 4 and the 2, which will give me a negative 8, so 36 minus 8 stays in the parentheses, 3 on the outside, plus 7 on the left. I will stick with what's in the parentheses. 36 minus 8 will give me 28. The 3 is still on the outside, and a plus 7 still remains. Now, 3 times 28 will be the next order, which will give me 84. And finally, with the plus 7, I can do the addition at the bottom of my order, which will give me a final answer of 91. These problems can get a little bit tedious, but with the correct order and careful math, the correct solutions can be found. Taking a look at another way that things are written, what if I have a 2 with a fraction bar and a 4? Well, this is also known as division, and we look at that as 2 divided by 4. In our second example, we'll see how this is played out. 5 to the power 2 minus 3 times 3 over 3 plus 5 in a parentheses minus 6. That fraction bar essentially states that both the top and the bottom, as we just saw, are in their own parentheses. So let's work on how we solve this extensive problem. I handle the parentheses a step at a time. 3 plus 5 in this parentheses will give me 8 minus 6, and that'll complete my bottom parentheses for now. Keep my big fraction bar, and in the top parentheses, I'll take 5 to the power 2, get 25, minus 3 times 3. I'll solve the bottom parentheses now. 8 minus 6 will give me 2, and there's nothing left down there. And 3 times the 3 on the top takes precedent, and which gives me 9. So now I have 25 minus 9 on the top, which I can easily solve. Now at this point, we might be tempted to divide 9 by the 2, but we must remember that we still have the parentheses between the 25 and the 9, so we'll subtract those instead and give us an answer of 16. Now that we have 16 alone and 2 alone, we can do 16 divided by 2, which will give me a final answer of 8. So as we can see, a very long problem, but done correctly, can give us a good result. There's a way to remember order of operations. A good way to remember order of operations is think of the word PEMDAS and what it could stand for. PEMDAS, or Please Excuse My Dear Aunt Sally, can help us remember this order. You might be wondering, how important is the order? Will numbers and answers actually be different if done incorrectly? Well, let's look at this problem. 2 times 15 plus 16 with the 15 and 16 in parentheses. Let's do it the correct way, and let's say that if we follow the parentheses, 15 and 16 will be 31, and 2 times 31 will give me 62. Let's do it the wrong way, and let's say 2 times 15 will give me 30, and then at the end I'll add 16, and it'll actually give me 46. Done correctly, we get one answer. Done incorrectly, we get a completely different answer. That does not work because it did not ultimately follow the order of operations.